we are ready to start?
Yes, please take it up.
All right, excellent. Okay, let's go to the first slide. So yes, as mentioned, we're going to talk about the impact of 5G on the network and how things are going to radically change. And I know that we've probably heard this many times with many different technologies, many different inflection points throughout the previous numbers of years. All different types of things are going to change. I think this is one of the areas where we do see a lot of potential. 5G is going to open up a tremendous amount of data for all of our customers. And really what that means is that the way that we've designed networks, deployed networks, the way we manage networks will change substantially. So really there's three different areas that we're looking at. We're looking at scalability, we're looking at composability, and visibility. Now you look at scalability and you think, yes, I know what that means. I have to, add more bandwidth. But I'm going to talk in terms of how the circumference of the data center is going to change and how 5G is going to necessitate that moving forward. So it's not necessarily just scaling within the data center or scaling bandwidth between data centers, but it's really just the fact that there are going to be a lot more data centers. Composability is really about the ability to change quickly. And so we've talked about this many, many times in the past, the programmability of the network, how important that is, how important it is to be able to adapt to change. I think it's going to become even more important as we move forward. So we'll talk a little bit about how does composability help and really put you in a position to react much faster. And then lastly is visibility. And we've been talking about visibility for a long, long time. Again, as we distribute more data centers, as we have more data traversing the network, we have more points that we need to see into. We need to look deeper into the traffic across the network. So visibility in the past was one of these nice things. I really used it more from a reactive troubleshooting perspective. Now I really need to think about it more from a proactive and how can I make adjustments to the network before there's a problem. And so we've talked about AI and ML and the cool things that we can do with that. Those things are becoming a reality today and will become more so in the future because of just the sheer amount of things that we have to do. We're going to have to rely on the tools to help us through all of this. So if we look at the data center itself, as I said, the bandwidth inside the data center is growing. Compute are moving to 100 gig much quicker than in the past when we had different bandwidth increments. Therefore, inside the data center, the traditional leaf and spine moving to 100 gig and 400 gig, the spines moving to 400 gig. All of these things are starting to happen at a fairly rapid pace. Unfortunately, the cost hasn't quite caught up, and so the cost of 400 gig is still rather expensive, more so with the pluggables and the optics. But like everything else, those numbers and those prices will come down over time. So the move to 400 is happening rapidly. And again, we're already talking about 800, we're talking about terabit. It's going to continue to cycle. But again, I think bringing it back into the context of 5G, why is that important? Really just because of the volume of traffic and the volume of applications and the volume of data that is continuing to increase at a really, really high rate of pace. And so our ability to create the infrastructure to be ready for that, very, very important. When we look at, especially inside the data center, having an architecture that is easily expandable, very quick and easy to add bandwidth to, add capacity to, along with serviceability, those things have really become table stakes at this point in time. So if we look at a second piece, something that we may or may not think about from a security perspective, it's something that we call trusted delivery. And trusted delivery is really about ensuring the integrity of that hardware and software from the time it leaves the manufacturing facility, going through distribution, and getting to your data center, getting to your doorstep. We want to make sure that we ensure that nothing has been tampered with. We want to make sure that nothing has been put into the switch or the router that would create a potential backdoor, create a potential security threat. I think we've all seen in the industry here, just in the recent 6 to 8 months, multiple situations where this type of thing has happened and causes obviously some significant concerns. So we're doing a lot to ensure that when you get that switch or that router and you plug it in, you know that it's not been tampered with. You know that it is 100%. The integrity is there. What is intended to be there is at that point. So then what do you do from there? Well, from there, you boot the router up and you put it on your network. I think the next step is kind of in between that switch booting up and it actually being on your network is technologies like secure boot and measured boot. Now, these are not new technologies. They've been around for quite some time. I don't think they've been really widely implemented because it does take some additional infrastructure. But at this point in time, every step along the way is critical and important. So we want to make sure that when the platform gets to my doorstep, I don't have to worry. And then when I boot it up, I can take it through a secure boot process or a measured boot process. And now when it actually is on my network, I have all of this baseline where I know I'm working from a known good and secure entity. So in this day of cybersecurity and all the different things that are happening in the world, every single step that we take to ensure security is something that we have to do. It's no longer, it'd be nice to do this. Maybe I'll do this. Maybe we'll implement this in the future. These are things that we absolutely have to do at this point in time. And then once we get into the switch and the routers booted up, then we get into all of the traditional, what we normally talk around security from access control lists and things of that nature. So none of that really changes. This is more precursor to that box getting to that point in time. So something to think about, something to consider. I think it's vitally important, like I said, to give you the assurance that what is there is a known entity. So now the data center, creating a robust infrastructure. Again, this is nothing new. Redundancy, resiliency, reliability. These are all things that we've taken into account for ever, basically. It has gotten much better over time. The technologies have evolved. The feature sets, the capabilities have evolved. And so we can have multiple redundant physical connections. We can have multiple logical paths through the networks. We can create, the sub-second failover and recovery for planned and unplanned outages. But now we're taking it to really the next level. And so I throw there in the middle of the chaos monkey. And so doing more chaos monkey testing of the topologies and the architectures, again, really ups the level of this robust infrastructure. So again, pulling it back into 5G, why does this matter for 5G? Well, with 5G, we see a much more distributed architecture. So networking infrastructure is pushed out farther and farther to the users, as we talked about expanding that circumference of the data center. So now I have equipment dispersed geographically all over the world. And you probably have this today, but now it's going to get pushed even farther and farther out. And whether it ends up being switches in the bottom of a cell tower hut or switches that are deployed on a customer premise Those types of things now get farther and farther out. Now, the farther away they get, the less control we have, and the more things that can go wrong. And so we've really implemented much more stringent testing to ensure a robust infrastructure. And so as you start to think about and how you test your infrastructure and how you put things in place, in the past, we always thought about testing for a single point of failure. The redundancy, the reliability, all of those things allowed us to create an infrastructure that could withstand a single point of failure. So if one thing failed, that's okay. I want my service not to be interrupted. I may take a bit of a hit, maybe on bandwidth. I may have a 500 millisecond failover, those types of things. But now, from an architecture standpoint, we're actually testing for double faults. So what happens when two things fail at the same time? Now, you may step back and say, that won't happen. Yes, unfortunately, it has and it can happen. And when equipment is farther and farther out of reach, it becomes much more critical to have this robust infrastructure. Now, it's obviously critical inside the data center. If something fails, that's a bad thing. But if it's inside the data center, normally there are people available to go and physically make changes, power cycle it, pull cables, replace the switch. As these devices get pushed farther and farther out, and we have a switch that's on the top of a mountain at the bottom of a cell tower, it could take days to get somebody out there to physically have to make changes. And so this robustness really says that, I can't help an equipment failing. If a power supply fails, a power supply fails. It's electronic equipment, these things will happen. But it's really about the reaction of the network and what happens at that point. So really the ability to create the most robust infrastructure possible for this distributed architecture plays well into the centralized data center too. So creating this infrastructure that says I can not only withstand a single failure, but I can withstand multiple failures is critical. Now, all of these things kind of play into it also from a standpoint of the known good configuration and operation of the network. And we'll talk a little bit more about that as we get further into the presentation. But keep that in mind too, that when something fails, the network keeps operating. When something fails, things keep being changed from a configuration standpoint. So what happens now when the failed component comes back online? So again, we'll talk about that here in just a minute. So kind of wrapping the scalability piece up, it really is about expanding the circumference of the data center. So the centralized data centers will still be there, absolutely. But the sheer amount of data that will be generated by 5G and by all of our customers would put such a stress that the centralized data centers simply can't handle all of that. From a bandwidth perspective, from a latency perspective, performance that's going to be expected by our customers. So the concept of applications moving out closer to the users, again, not necessarily a new concept, but hasn't really been a pervasive concept. So now we have this idea of the edge compute. So the multi-access edge compute, the MEC solution, putting applications and putting those services closer to the users. So that means that in today's environment where I may only have a handful of centralized data centers, which still is a lot of work to maintain and to manage, all of a sudden now it turns into 1,000 data centers that I have to manage. Now those 1,000 data centers may only be a couple of switches and 10 compute, but the sheer number of them is pretty massive. So they all become part of the data center. They all become part of this holistic thing. And we've talked that the data center lines have blurred. And that was more so from maybe data center interconnect, maybe from an on-prem data center to a cloud data center for our customers. But now it's really the sheer amount of data center will continue to expand. So that means that I'm going to improve the performance and the service to all of my customers, but now it stresses me out in multiple different ways because I'm not only just worried about all of my infrastructure inside the centralized, but now I have to worry about the infrastructure everywhere, geographically dispersed. And this is happening. I mean, this is happening already. The likes of Google and Amazon are putting servers, cache servers, in the cell tower huts. They want to get that as close as possible. And we look at 5G and we talk about what are the killer applications for 5G? Some we know, most we don't. It's one of these things where we know it's coming, and we want to make sure that we're prepared for it. If we wait till it hits, then it's too late. We're already well behind the curve. So when you think about different applications, the collection of data for self-driving vehicles, those types of things, tremendous amounts of data that are going to be dispersed all over the place. Or it could be things like esports and gaming, where latency is massively critical for the performance of those types of applications. So it's going to be just about anything you could probably think of, and a lot of things we haven't thought of. We'll continue to push and to stress all of the networks. So really, again, I want you just to start to think about how you're going to architect and how are you going to do things moving forward. Because if we try to deploy all this 5G and we use our existing network infrastructure, we're going to have problems. It's inevitable, whether it be bandwidth, performance, a combination of both. And then we're going to be scrambling to try to catch up, to try to deploy something to now fit what's happening in the world. So we have a bit of a head start here, and 5G has been deployed to some extent. We're barely scratching the surface of what's there. So now it's only going to get bigger and faster. So we want to make sure that we have ourselves as prepared as possible when it comes to the scalability piece. So now if we look at that in terms of visibility, and these play very well together. So now I have a whole bunch of points that I now need to look into. So visibility is really, the way I term it is turning data into actionable information. I can have tremendous amounts of data. And, 25 years ago, we would take a network sniffer and we put it in the network and we would look at data and try to figure out what's going on and find out where the problems are. Those types of things, although they still probably happen and need to happen today, we now must take it to a much higher level into what it is we're looking for. So the amount of traffic, there's just a lot of traffic out there. So that means that there's a lot of visibility points. Those visibility points, turn into action points. So what does that mean? Well, really what I need to be able to do is understand what's going on in my network at all points, at all times. But my network's getting so much bigger. How am I going to physically have time to look at all of this data, all of this information? So it's kind of like, you take all this huge amount of data, and now I funnel it down into something called information, which means that it's something that I can really, understand and take action upon. And so doing that is awesome, and we can do that today. But think about it as it continues to expand and grow. So today I have maybe 100 different action points, and I have 50 different things I need to look at. Just throwing numbers out there. But what happens when that turns into 10,000 action points, and I have thousands of things around information that I really need to look at? So that's where the concepts of machine learning and AI come into play. This is, again, it's not if we're going to implement it, it's really when we're going to implement it. We're going to be forced to, because there's going to be so much happening so quickly that it would take an army of people full time just to try to keep up, just to try to see what's going on in the network. And with the customer expectations going up higher and higher and higher, better performance, better availability, lower latency, everything just has to work. I have two things that failed in the network at the same time. Everything still has to work. We have to have that visibility into the network, and it has to be not only the reactive go and troubleshoot things. That's still going to happen. We're still going to do that. There's no doubt about that. But it has to be proactive. I want to know where the hotspots are on my network so that I can move traffic. Some of this happens today. Some of it happens somewhat automated. Maybe a lot of it happens manually. But moving forward, I really just need the network to be able to do this for me. So the first step is that I need to know what's going on. And visibility is really not just at a packet level or a frame level. It needs to be higher level from a concept of the user, the application. So now it's much more important that I see it from an application view, not just packets flying across the network. So I need to know, how is my application running? How are my users reacting to that application? What performance are they getting? So visibility becomes a massively important thing to see this, again, not just reactively, but proactively. So if we look at, there we go. Let's move into composability. So composability, and I think at the bottom of the purple box there says it the best. If customers are moving fast, you have to move faster. So what your customers are going to do is changing very rapidly. We all know that. We need to stay a step, or hopefully 2 steps ahead of them. And so putting an infrastructure in place that is composable, what does that mean? Well, that means that I can streamline it, I can customize it, it's really programmable, but it really creates an infrastructure that has the capability to, forward packets as normal, right? Forward those applications, create those services, but also have the visibility built in at the same point in time. Now, I also need to make sure that this is all done in an automated fashion. I want to continuously automate. I want to continuously validate the infrastructure that goes in place. And so you may think, oh, composability is really, we've been doing this forever. I think we need to take this to a much higher level than what we've been doing today. We've had multiple tools in place to do multiple things. We've had multiple networks in place. In some cases, we create a production network, and then we create a visibility network or a tools, analytics, packet broker type network. 2 totally separate networks, managed differently, different applications, different hardware, performing very important and vital things, but those things need to merge together. And we need to be able to do all of this from a single point of entry, a single application. So it's something that we talk about in terms of hyper-automation. So hyper-automation really takes us into a place where we can, let's slide that over, please. There we go, thank you. All right, so hyper-automation really takes management to a whole new plane. And so this is just a very high-level, rough architectural picture looking at centralized data centers, access data centers, the MEC solutions, but creating an automation solution that is much more than just an automation solution. This is about the ability to discover, validate the network from a physical topology standpoint, then automate the network and the tenant provisioning across the network. Okay, so all those things pretty much exist today. That's really nothing new. That's pretty much table stakes. But now we look at the next piece of this as far as drift and reconcile. And that really goes into with continuous monitoring, continuous validation. So let's step back just a little bit to when we talked about the data center. Oh, sorry, let's go back one slide. There we go. Let's step back into where we talked about the scalability of the data center, and then the resiliency, the reliability. I have a switch go down, but I'm continuously provisioning tenants. Now that switch comes back up, what happens? That configuration is no longer the same as the rest of the network. So we need to make sure that the network is always in a state of known good and valid configuration, regardless of what happens. So at no point in time should a switch or router ever come up on the network that doesn't have a valid configuration. And so part of this concept of hyperautomation is that I have a single source of truth, and that single source of truth maintains the integrity, I'll use that term again, of the network itself. So I know at every point in time that the configuration is known and good. If drift happens because maybe someone manually goes in and makes a change, the hyperautomation will go out there and ensure that I reconcile that back to the known configuration. So this piece is really the glue that brings it all together. If we look at the scalability piece, okay, we're going to have a lot more data centers. We're going to have a lot more visibility points. So now I need to have an application that really provides me the capability to pull all of this together. It needs to be a single application. I can't have an automation application and then a monitoring application and then a visibility application. We've had this for forever, and the promise of bringing this all together has been there forever too. And so we're making good strides as an industry to get to that point. The fact that all of these things are very well interconnected, and really AI and ML are going to be key components in how that is brought together. Because on one side, I have the provisioning of the network and the automation of the provisioning, but it needs to be fed information. Now, today, that information is normally fed from a human, putting something in. But moving forward, that information can also be fed from the network itself. So the ability to now remediate. So the automation piece doesn't really care who's telling it what to do. It's just going to do. So all of this really, comes together and has to be fully intertwined and interconnected to make us efficient moving forward. So let's summarize where we've been. We look at the concepts: scalability, visibility, composability, and hopefully you can see that they are all interlaced together. They're all interdependent and reliant upon each other. So as 5G presses the network, pushes us beyond what we think we can do today, we need to figure out how we're going to scale. Okay, so now we know we're going to need to scale, but we also know that in 6 months, in 12 months, in 18 months, things are going to change. So how do I stay ahead of my customers? How do I react to that? And really, I want to be proactive. I don't want to react. I don't want the customer to tell me. I want to be already in the position where when they come, it's like, yep, we're ready. Bring it on. So the composability piece is I want to put this infrastructure in place, but I really don't want to put this infrastructure in place again in 12 months because I'm not able to provide the services my customers need. So I want to put that infrastructure in place one time, and then I want to be able to just morph that infrastructure into whatever it needs to be based on where the industry is going. So I need to be able to compose it. Now, how do I compose it? Well, I got to have an application to do that. So the concept of hyperautomation says that is key to being able to compose the network. And that is also key to the visibility piece there in the middle. And like I said, they all tie and they all interlace together. So, in summary, I think, if you can take anything away from this, it's the fact that 5G is going to change your world. And really, we need to think about what it's going to be and how we can best position ourselves for that. And with that, I'm all done.
Well, thank you very much, Dan DeBacker, for your contribution. Perhaps I can summarize 5G is a big challenge, but you guys are ready for it.
I want to make sure that we're all ready for it. I think that's the thing we all need to think about. We all need to get ready to do this together. And so that's really the thought here.
Yes, yeah. Talking about extreme networking. Actually, it makes the name of your company quite literal. There were no questions on the chat now, so I leave you to it. Again, respect that you woke up at, that you were here at 6 in the morning from Montana. So I don't know if you go back to bed or take a strong coffee and go jogging or anyhow, but very nice to have you with us. Thank you very much. Dan DeBacker.
Okay, thank you very much.